Donations to a local charity are normally distributed with a mean of 75 and a standard deviation of 20. I have truncated that for you and just given you the information you need. The mean is 75, the standard deviation is 20. We're looking for the probability that somebody randomly selected donation is more than $90. So, how do you go about doing it? First thing you better do is draw your picture. Mean goes in the middle, 75. More than 90, 90 is on the right-hand side. Remember that this acts as a pseudo number line. Okay, so if you ever get confused about where is 90 at, and it happens. I mean, I'm telling you, it happens. I've seen a lot of people who don't know where 90 goes. It makes a big difference which side you put it on. Why? Because more than 90 is this side. Okay? That's a small area. And that's going to become important when we start to look values up on the chart. So, when we do this, we're going to use the formula Z equals X, X, not X bar, just X minus mu divided by sigma. So this is going to be 90 minus 75 divided by 20. Now, here's what I know. That most of you, some of you, are calculator dependent. And you know what? I'm ready to embrace that. So let's do it. 90 minus 75. Make sure you put the entire top piece in parentheses, divided by 20. Now, you will not see me doing things like 90 minus 75 and pressing enter. And the reason why I don't do that and then hit an answer divided by 20, the reason I don't do it this way is because long term that's going to hurt you. Short term it's not so bad. Like for the problems that we're doing today, for problems that we're doing tomorrow, it's probably not that big of a deal. Long term throughout the course, doing them in pieces is going to hurt you. So get to where you start learning how to type them in all at one time and you'll be a whole lot better off. Okay? You just got to trust me. I've been doing this for like 3 weeks now, so I've got the hang of it. Okay. So, 90 minus 75 divided by 20 is 0.75. So, this is 0.75. Now, here's the major thing. Here's the major thing. We're going to go to the charts. And I have to know, am I looking at the positive chart or the negative chart? Okay? And how do you tell? Well, the way you can tell is look at the chart. This is a small area, right? That's a small area. If you look at the other one, oh, that worked great. We're going to go to the negative chart. And we're going to look up 0.75 on the negative chart. Now, when you look up 0.75 on the negative chart, and you just have to trust me for those of you watching at home, I'm looking it up on the chart. Can't show you that I'm looking it up on the chart because I closed it, but I am. You get 0.2266. Now, what I see a lot of people do is they look it up on the positive chart because the number they got was positive, so they figured if there's a negative chart and a positive chart, it's probably best to use the positive chart since my answer was positive. Those people clearly aren't very well informed. If you do that, no offense, if you do that, when you look it up, you get 0.7734. That's not right. Then you'd have to subtract from 1. Okay? And it's not that big of a deal to do it that way. I mean, you know, if you weren't informed and you looked up the positive chart, you just have to subtract from 1. You get the same answer anyway, so it's no big deal.
That's what he would teach me.
Right.
It gives me an extra step, though.
And it gives you an extra step. I'm lazy. When I run, I look for a golf cart. I'm lazy. I want to ride to the finish line. And I can get out. Okay? Take the negative chart, small area. You want to start getting to the hang of small area, big area, looking them up as needed. Now, going to the next one, less than 65. Less than 65, here's 65, here's 75. 65 minus 75 divided by 20 equals, here we go again. Open parentheses, 65 minus 75, close parentheses, divided by 20. Negative 0.5. We'll go ahead and capture that as well. Okay. Now, just out of curiosity, or just as an observation, if you ever do this, and let's face it, you know, I mean, they tell you not to drink bleach if you ever read the damn instructions or at the bottom. I mean, I swear to you, I'm not kidding. They tell you don't drink it. Right, Brian? That's what it says on the label. Don't drink it. But then right after that, what do they say? In case you do, which I yet to figure out, call poison control. Don't induce vomiting, call poison control. Now, I'm going to tell you not to forget to put those in parentheses like that. But in case you do, how are you going to know you screwed it up? When you get a z-score of 61, now remember the empirical rule said what? 99.7% of data is within 3. I don't know what percentage is within 61. Okay? Remember that that's a z-score. That number should be somewhere between -3 and 3. Now, will it be between -3 and 3? Should be. I mean, will it always be? No. There's always a test question that it's not, just because I want to screw with you. But it will never be 61, Anthony. Okay?
Because I'm dumb.
No. No. You work hard.
That's not what it sounded like.
No. Oh, yeah. Well, if that's what it sounded like, that was not an implication.
I'm just kidding.
So, -0.5. Small area, big area? Small area, so look up the negative value. And what do you get?
0.3085.
0.3085. Although I am coming to gather that I'm probably one of the few instructors who teaches positive negative system the way I do.
So we looked on the negative on both things.
Yeah, because both of them were small areas.
So the negative side doesn't really do anything.
No, the negative sign here is of no consequence to me, really.
Okay.
So always remember that.
Yeah, that sign there doesn't tell me anything.
So if we could just go by the rule, if it's smaller, look on the negative, and if it's larger, look on the positive.
Right.
Because that's not what it is.
And what did you get?
0.3085. Okay. Now, for this one, for the top 2%, this one's a little bit different because the top 2%, and if I had the chart pulled up on the computer so nicely, it'd be easy to see. But you're just going to have to trust me on this one, okay? You're looking for 0.0200 on the inside part of the chart. Now, I don't know for sure what happens when you do that, but what I think happens is if you go down to somewhere around 2.0, and then you go across the top to 0.05, if you look down there, that number is going to be roughly, I don't know for sure, but 0.0202 in that general vicinity. And if you don't believe me, I'll bet you a bagel. You're going to get 0.0202. Now, the one next to it's 0.0197. The one next to it's 0.0197. Possibly. Maybe I'm wrong. Or not. This one is closer to 0.02 than this one is. So you take the one closest. This is not like Cliffhanger on Price is Right, where it's like the little guy goes up, and you have to stop him before he falls off the cliff. That's not this. This is not up to, but not over. This is take which one is ever closest to it. So 0202 being closer to that than this one is. Now, how do I know that? This one's only 2 10,000ths off. This one's 3. Okay. So the top 2% means this area here is 2%. which makes this value here 2.05. Now, what you'll say to me is, but whoa, Dreyer, we're on the negative z-score chart. Remember that z-scores fundamentally are start at zeros in the middle, right? So if we're on the right-hand side, that would have to be a positive number. If we were on the left-hand side, you know, like we wanted to tell people who were in the bottom 2%, hey, thanks for your donation, why don't you give us more next time? Then we'd go isolate the bottom 2%, and that would be a negative number. Okay. So what you're going to have to do is 2.05 equals x minus 75 divided by 20. Now how are you going to solve? Multiply both sides by 20. So this is 41, am I right? X minus 75. $116. So I can't even use the damn calculator. I'd do better if I just looked the thing away and then plus 75. Okay. Giving you a final answer of x equals 116. All right. Any questions on that?
How did